This is a tutorial on how to solve problems involving the relationship between pressure and temperature. A cylinder of gas with a pressure of 200 kilopascals and a temperature of 500 Kelvin is cooled until it has a pressure of 50 kPa. What is the new temperature? You do have to know which units correspond to which variable. If you're not sure how to do that, please go back to your notes. I'm going to go ahead and fill in all the numbers that were given to me first. A cylinder of gas with a pressure of 200 kPa, so it does say that it's 200 kPa right there, and a temperature of 500 Kelvin, is cooled until it has a pressure of 50 kPa. So my final pressure is 50 kPa. What is the new temperature? So what is the final temperature? So that's the one I'm going to mark with X. Okay. I need to figure out what happened to my variables. I remember that the pressure-temperature relationship is direct. And we know that from the simulation that we've done in class. I know that the pressure went down, and direct relationship means that I can expect the same from the temperature. The temperature should go down. All right, so we're going to go ahead and try to solve this right now. So for every 200 kPa, there is 500 Kelvin. Okay, so for every 50 kPa, there is blank. I know that pressure went down from 200 to 50, and in order to go from 200 to 50, I have to divide by 4. So we divided this one by 4 to get 50. We're going to have to do the same thing to the temperature. We're going to divide this one by 50, and when we divide 500 by 4, we get 125 Kelvin, and that's my final temperature. This is what the temperature is going to be after the pressure drops down to 50. Now we're going to do our particle picture. Since number of particles is not changing, remember they didn't mention it, so that's constant, neither did the volume. That means that the particles are contained in the same size box, and we have the same number of them. So I'll do 3 and 3. Temperature has changed. The final temperature was higher, so I'll do 2 whooshies. And then the final temperature was lower, so I'll just do 1 whooshy on these. Alright? What's changing also is the pressure. So the pressure did stay, the pressure is higher at the initial state, so I will show just those 2 whooshies kind of bouncing off of 2 different particles. And at the final, I only will have 1 particle bouncing off the wall. All right, thank you.